All right, we have now learned a ton about DeFi, and hopefully I piqued your curiosity on how much more there is still to learn. But now we're going to move on to creating our own stablecoin here. So again, you can follow along with all the code that we're going to be going over in this Foundry DeFi stablecoin F23 section of this course. And like I said, I'm planning on getting this code actually audited. So be sure, if you have your GitHub repo, be sure to watch this repo and look for updates, because I will be posting the audit reports in this as well. I've got a couple videos on what smart contract audits are and why they're so important, and I'll leave a couple links in the GitHub repo associated with this course. For those of you looking to go down the security track, definitely be sure to watch this video. But all right, we are finally in our GitHub repo. Let's build this stablecoin. MKDIR, Foundry, DeFi stablecoin, F23. Let's open this up with code, or you know the drill, file open folder. We're going to be going a little faster this lesson because a lot of what we're doing is just going to be drilling in information that you already know. We have a couple of new things to go over, such as stateless fuzzing, which we'll talk about in a bit. But a lot of the coding aspect of this, you already know. All right, we're in our folder. Forge init, clear. Let's make a little README over here and talk about the design of our protocol. So we're going to make a stablecoin. But if you watch that stablecoin video, we're going to make a stablecoin that is one, anchored. So when we're talking about the relative stability, it's going to be anchored or pegged to the US dollar. So this means we're going to have to put some code in here to make sure that our stablecoin is always worth $1. Number two, the stability mechanism, or the way we do minting, is going to be algorithmic. This means that this is going to be a decentralized stablecoin. There's not going to be any centralized entity that's going to mint or burn or maintain the price. This is going to be 100% on-chain and algorithmic, which is ideally what we have for the future of stablecoins. There's no controlling entity that controls our stablecoin. So this is great. A better stablecoin for Web3 probably isn't anchored or pegged. It's probably floating, but that's a much harder mechanism to do. So we're going to go ahead with the anchored or pegged for the moment. And then finally, the collateral type is going to be, you guessed it, exogenous. And it's going to be crypto collateral. We're going to use cryptocurrencies as collateral for this currency. We're going to use Ethereum and Bitcoin as the collateral for our system here. So with this being our architecture, we're going to keep this in mind. Okay, how can we actually make sure that this is always pegged to $1? And one way we can do this is with a Chainlink price feed. So with a Chainlink price feed, we get the price feed and we set a function to exchange ETH and Bitcoin for whatever their dollar equivalent is. And this way, if right in our contract we have this exchange set up, the price of this stablecoin should hypothetically always be around $1. To make the stability mechanism algorithmic, we're going to say people can only mint the stablecoin with enough collateral. And that's going to be coded directly into our protocol. And the collateral type being exogenous, of course, we're only going to allow these two types of cryptocurrencies to be deposited. Specifically, we're going to use wrapped ETH and wrapped Bitcoin. So the ERC20 version of ETH and the ERC20 version of Bitcoin. Some might argue that this wrapped Bitcoin is a little bit centralized depending on who is onboarding the Bitcoin into Ethereum, but that's another conversation. So over collateralized stablecoin with WETH and Bitcoin as the collateral for this. Let's do this. So the first thing we're going to do is we're going to get rid of all these. Goodbye, delete. And now we're going to create our two main contracts. New file, decentralized stablecoin, do a capital C .sol. And this is just going to be the actual token. So I'm actually going to copy paste my layout of functions because I like them. I like to have this. And at the top, of course, SPDX, license identifier, MIT. If you want, you can just copy this directly from the GitHub repo associated with this course, SRC, right in here, copy this layout here. I like to have it as a reference. Then you already know, Pragma, Solidity, 0.8.18. And we'll do contract decentralized stable coin. Boom, like this. And now this is going to be one of the main differences between this code we're writing here and all the other products that we've done. We're going to be very verbose with our code documentation. And the reason for this is when it comes to security professionals who are going to review this code, we're going to make their lives so much easier if we have a ton of text explaining what our code is doing. Additionally, if you work with AIs are fantastic at reading and understanding language. So the more language that we have to explain what our code should do, the better off our code can be sent through some AI model to make sure that it doesn't have issues. So we're going to go ahead, add a little bit of NAT spec here, right from the get-go. Add title, decentralized stablecoin, all one word. At author, Patrick Collins, or put your name here. Yep, this is open source, MIT license. You can do whatever the heck you want with it. I'm even going to say collateral, exogenous, ETH and BTC. Minting, or the stability mechanism, is going to be algorithmic, meaning it's decentralized. Relative stability is going to be pegged to USD. And then I'm going to say under here, this is the contract meant to be governed by DSC engine. This contract is just the, I'm going to toggle word wrap here, ERC20 implementation of our stable coin system. So that's what this is going to be. This decentralized stablecoin is purely going to be an ERC20 with minting and burning and stuff, right? It's not going to have any of the logic. The logic is going to be in a separate contract. So let's go ahead and let's make this. So first, constructor, boom. And we're going to use OpenZeppelin to get this kick-started. So right at the top, import, well, actually, before we even do that, forge install OpenZeppelin / OpenZeppelin -contracts --no -commit. And we went ahead and installed that. Now we're going to open up our Foundry.toml. We're going to add some remappings in here. So remappings equals at OpenZeppelin /contracts equals lib /OpenZeppelin /contracts /contracts. That looks pretty good. Right up at the top of this now, import, little named import, ERC20. We're going to import this ERC20 burnable contract. I'll explain this in a second. And then also ERC20 from at OpenZeppelin /contracts /token /ERC20 /extensions /ERC20 burnable.sol. Did I spell this right? Looks like that's right. So what did oops, looks like I spelled contracts wrong. Let's spell it right. Okay, cool. That looks good. Now what we're going to say is that our decentralized stablecoin, let me even zoom out a little bit. Yep, this is going to be a big one. So we're going to zoom out a little bit here. Hopefully you all can see this, is ERC20 burnable. Okay. And the reason that we're going to use this contract, if we command click in it or just look it up, is it has this burn function. And we want this burn function because this is going to help us maintain the peg price. We're going to be burning a lot of these tokens. You'll understand that in a bit. Now, same as an ERC20. So the ERC20 burnable contract is an ERC20, which is why we can import the ERC20 contract from it as well. And the ERC20 burnable constructor is an ERC20, which means we have to use the ERC20 constructor as well, which takes a name where we're going to call ours decentralized stablecoin and DSC, like this. And that's it. This is going to be our whole constructor. We're not going to touch it. That's all we're going to do. Let me zoom in a little bit. I'm going to keep zooming in and out. Hopefully it's not too crazy. Now, we want this coin to be 100% governed by our engine. And our engine is going to have all this stuff about what collaterals to use, how to use it, what to peg it to, etc. This is purely just going to be the token. So since we want this token to be 100% controlled by our logic, we're going to make this ownable as well, which means we're going to have only owner modifiers where the owner is going to be that immutable logic we're going to create. So OpenZeppelin has a package for that too. So we're going to do import ownable from @openzeppelin/contracts/access/ownable.sol. I'm going to copy this. So our contract is going to be ERC20 burnable, and it's going to be ownable. And there's going to be two major functions that we want our engine to own. And those functions are going to be function burn, where it takes in a uint256 underscore amount public. We're going to override the burn function in burnable. And this is going to be only owner, so that only the engine, only the logic that we give it can mint and burn. And we're going to say uint256 balance equals balance of message.sender. And we're going to make sure that when somebody tries to burn some token, they at least have that much token. So we're first of all going to say if the amount is less than or equal to 0, then they can't burn, right? We don't want people to try burning 0. That's silly. So we're going to revert with an error. We're going to put all of our errors right up at the top here. Error, decentralized stablecoin __ must be more than 0, like this. So we're going to revert with this error. And then we're also going to say if the user's balance is less than the amount that they're trying to burn, then we're going to revert with another custom error. I'm just going to copy paste, and I'm just going to say burn amount exceeds balance. Boom, paste that in like this. And then finally, we're going to do this thing called super.burn, which we haven't talked about yet. So this super keyword basically says, hey, use the burn function from the parent class, which in this case is the ERC20 burnable. So all of this code is going to run. It's going to hit this line. It's going to say, hey, go to the super class and use the burn function there. So our code's going to go, oh, okay, well, ERC20 burnable, that's the super class or the parent class. Just use the burn function in here, which calls the burn function here in the ERC20.sol, which does all this stuff in here. So that's what the super keyword does. Only owner, only engine's going to add this. Now we're going to do this function mint. This is going to be an address 2 and a uint256 underscore amount. This is going to be public. Excuse me. This is actually going to be external. Also only owner. This one probably could be external as well, but that'll come out in the audit. External only owner. And this is actually going to return a Boolean. When you do mint, you want to have a return a Boolean here. When you do a mint, we're going to return true if it actually works. But we're going to say if 2 equals address 0, we're going to do a little sanitization of the inputs here. Then we're going to revert with a new error, decentralized stablecoin, not 0 address. We're not going to let people accidentally mint to the 0 address because that happens kind of a lot. And we're going to say if the amount is less than or equal to 0, then we're also going to revert with this more than 0 error here. Boom. And then finally, we're going to return true. Oh, and then obviously we should run mint _2 amount. So we're not overriding any functions in here, right? We're just calling the mint function. Over here, we had to do super because we're overriding the burn function. And we're saying, hey, do all this stuff and then do the regular burn. There is no mint function. There's an underscore mint function that we're going to be calling. And guess what? That's it. This contract's done. We're not doing any more here. Forge, build, cool. And then we probably want to write some tests for this, write a deploy script, but we're going to do all that in a little bit.